In this video, we're going to talk about the greatest common factor and factoring by the greatest common factor, which we'll abbreviate with GCF. Now, before we start, we need to define what is a factor. A factor is a number that can be used to multiply to make another number. Now we also need to define what is a prime factor. A prime factor is a prime number that is a factor of a number. Now we're also going to talk about what is prime factorization. That's the first thing we're going to start looking at today. Prime factorization are all the factors, or it's what happens when all the factors are prime numbers. So we'll be breaking up a number into the prime numbers that make it. In fact, that's going to lead me into our first example. We are going to write the prime factorization of the number 60. So what we're going to do is we're going to just break up 60. What numbers can multiply to make 60? Well, we can break it up into 6 and 10. You can break it up into a lot of different numbers, but 6 and 10 are some of them. We can break 6 up into 2 and 3, and 2 and 3 are prime numbers, so we can't break those up anymore. 10 we can break up into 2 and 5, which those are both prime numbers as well. So the prime factorization of 60, we're going to write them in order from smallest factors to biggest. We've got 2 times 2 times 3 times 5, but if we have multiples of the same factor, we can write it once with a power to represent how often it repeats. So we can write it as 2 to the power of 2 times 3 times 5. That's the prime factorization of 60. Now I've got another word we need to define, and that word is going to be greatest common factor. So we are going to use the greatest common factor when we are looking at what is the shared factor of 2 or more numbers. So what do they have in common? In fact, let's just go straight into our next example. Example 2. We're going to find the GCF, greatest common factor, of, let's do 24 and 60. So we are going to make factor trees with them. Find the prime factorization of 24 and 60. Well, 24, I can break that up into, let's go 3 and 8. 3 is prime, so we're going to leave that alone. 8 we can break up into 2 and 4, and 4 can go into 2 and 2. 60 we're going to then break up. So 60, we just did that. We know that is 6 and 10, and 6 is 2 and 3, and 2 and 5. So I'm now going to go, and I'm going to circle what they have in common. I see that both have a 3. So we're going to use that. I also see that both have a 2. In fact, I see that they both have two 2's. Now, 24 has an extra 2. We can't use that. 60 has a 5, but 24 doesn't, so we can't use that either. So our GCF, greatest common factor, is going to be 2 times 2 times 3. Well, 2 times 2 is 4, and 4 times 3 is 12. So 12 is the greatest common factor of 24 and 60. It's a number that's smaller than both 24 and 60, but it's the biggest number that's smaller than 24 and 60 that goes into both 24 and 60. So I want to also do this if we involve variables. So let's look at what that looks like. Example 3. Let's find the GCF of, let's take 3x cubed and 6x squared. Well, what I'm going to do is I'm going to rewrite this as the prime numbers that make up both terms, and then I'm going to break the variables up. So for 3x cubed, I'm going to break it up into 3 times x times x times x, and then for 6x squared, I know 6 is 2 times 3, and x squared is x times x. So I notice that both have a 3, and both have 2 x's. So my greatest common factor will involve 3 times x times x. Well, and x times x, that's x squared. So we can say our greatest common factor is 3x squared. I want to look at one more that involves variables. So we call this one we just did 3a. Let's do a 3b. We're going to do the same thing, but the numbers or the terms are going to be 4x squared and 5y cubed. So if I break those up, 4x squared is 2 times 2 times x times x. 5y cubed is going to be 5 times y times y times y. Well, they don't have anything in common, except we didn't write it. They do have something in common. In this case, if we can't find anything, the greatest common factor is going to just be 1. Because we can multiply both things by 1 and get their original selves back. So I also want to look at what happens if we are looking at polynomials. So here we just had monomials in example 3. Let's make a new example, example 4. And I'm going to look at a few different examples in example 4. If I have 4x squared minus 3x, we're going to treat this as two separate monomials and figure out what do they both have in common. So 4x squared is 2 times x times x, and 3x is 3 times x. Well, they both have an x, so we're going to bring that out. We're going to factor it. We're going to reverse distribute this. So if we bring out an x, what's left if we take one of the x's out of 4x squared? Well, we're going to have 2 times 2 is 4, and we're going to have 1x left over. We're going to reuse the sign, the minus, and what's left of 3x when we take the x away? 3. So we're going to have x times 4x minus 3. That is our factored version of 4x squared minus 3x. Let's look at 4b. We're going to factor 10y cubed plus 20y squared minus 5y. We're going to do the same thing we did in A, but now we've got 3 terms. So we're going to write 10y cubed as 2 times 5 times y times y times y. 20y squared we can write as 2 times 2 times 5 times y times y. And then 5y, we can write it as 5 times y. Well, now we ask ourselves, well, what do all 3 terms have in common? Well, I do see that all 3 have a 5, and I see that all 3 have at least one y. So we're going to bring that 5y out. So we're going to write 5y times. Well, what's left in the 10y cubed if we took 5y out? Well, I see that we have a 2 and then 2 y's left. So we're going to have 2y squared. In 20y squared, if we take the 5y out, I see 2 2's and a y. So we're going to go plus 2 times 2 is 4y. Now 5y, if we take 5y out, if we divide by 5y, we're going to be left with a 1. So we reuse the minus sign and we put a 1. So if we factor 5y out of 10y cubed plus 20y squared minus 5y, we end up with 5y times 2y squared plus 4y minus 1. I've got 2 more to look at for example 4 here. So this is still example 4, but this is now part C. What if we want to factor negative 12x minus 8x squared? So again, let's write out the 2 factors we have. 12, we can write that as 2 times 2 times 3 times x. And we can write 8x squared as 2 times 2 times 2 times x times x. So if we circle the things that we see in common, they've got 2 2's and 1 x in common. So if we went 2 times 2 times x, we're going to have 4x. If we take that out, what's left with the negative 12x? Well, we've got negative 3, and what's left of the negative or minus 8x squared? We've got minus 2x. So that's one version of this, but because both terms also have a negative, we can also write this as negative 4x times 3 plus 2x. If we change the signs of the things in the parentheses, then we change the sign of what's outside of the parentheses. Got one more for you. Example 4D. I've got 5x squared plus 7. Well, 5x squared, we can break that up into 5 times x, and 7 is just 7. But they've got nothing in common. If this happens and we can't find any common factor, we say it cannot be factored. All right, I've got one last type of example, and then we're done. So we're moving on to example 5. We're going to take 7 times x minus 3 minus 2x times x minus 3 and try to factor this. Now, what we're going to do is we're just going to look. Do the two terms, and remember, terms are broken up by a plus sign or a minus sign. So if we put a line down the center through this, do the two halves have something in common? And the answer is yes. They both have an x minus 3. So we're going to bring that out. We're going to rewrite this as x minus 3 times, if we take x minus 3 out of each term, we're left with a 7 minus 2x. Done with that one. Let's also look at if I have negative t times t squared plus 4 plus t squared plus 4. Now we break this in half at that plus sign, and both halves have a t squared plus 4, so we're going to bring that out. Now what's left? Well, we've got a negative t from the first half, but what's left in that second half if I divide t squared plus 4 out of it? Well, remember, there is secretly a 1 right in front of t squared plus 4 in that second half. So we're going to put a plus 1 to wrap that up. And that one's done. I think let's do one more and we can call this lesson good. So 5c, we're going to take negative 3x squared times x plus 2 plus 4 times x minus 7. Well, if we break this up, I don't see anything in common on either side of that plus sign, so this one cannot be factored. That's what we'll say, cannot be factored. There's nothing in common to take out. And that's going to wrap up our lesson on the greatest common factor and factoring by the greatest common factor.